boys and girls. So today we're going to be combining two lessons because they both really have the same idea of learning about area. So as always, I want you to do the mental math. Your math message today might sound a little confusing. What it wants you to do is on this grid paper right here, I want you to draw one rectangle. So remember that looks like a box, okay, with one side that is 3 centimeters on one. So 1, 2, 3. And then the long side is going to have 5. So 1, 2, 3, 4, 5. Okay, and you're going to draw that as a box. Okay, then you're going to draw a second rectangle, so another one over here, but this one is going to be only 1 centimeter and then 15 centimeters going the other way. So I just want to see, can you follow those directions and draw that here? So today, again, we're doing both these lessons, and both of them, we're going to be determining the area of a rectangle by counting the squares. That's why we're combining these today, because I feel like you'll be able to do this together. Okay, this is part of our measurement standard. So last time we learned about perimeter, and perimeter was, remember, the perimeter. It's the outside. So what is our new learning? What is area? Well, I'm going to have you watch this video. Okay, and this is going to tell you a little bit about the difference between perimeter and area. Okay, because the area is in the inside. We're counting these squares. It's how much space is on the inside of the object. Okay, and we count those in standard square units. And we called it square units because we were actually counting how many squares can fit in the space. Okay, and when we think of the squares, we can think of it as square inches, square centimeters, square feet. Okay, it depends on what we're measuring. So for example, this one is going to be square centimeters because this is a centimeter here, 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 and here. Okay, all the way around to the area inside, right? This is a centimeter square. And so this is 1, 2, 3 squares by 1, 2, 3, 4, 5 squares. Okay, so perimeter is just going to be centimeters because that's all we're doing. But area is going to be the squares. That's when we actually count those. All right, so today let's practice counting squares. So here for my model, and I'm going to show you how I would solve using this. So the perimeter, remember, is the outside. So that would be 1, 2, 3 this way, which means it's 3 this way. 1, 2, 3, 4, 5, 6, 7, 8 here, which means it's 8 here. Perimeter would be adding that up. So 8 plus 8 is 16. 3 plus 3 is 6. And add those together. 6 plus 6 is 12. Okay, carry the 1. 1 plus 1 is 2. So the perimeter is 22 units. But the area is going to be the inside. So I need to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's 24 square units. Now, is my perimeter the same as my area? No. Okay, and that's okay. Sometimes they might be the same, and sometimes they might not be. So it's don't count just because they're not the same doesn't mean that it's wrong. Okay, make sure you're counting the squares and then counting the outside for the perimeter. So I'm going to have you guys practice this here, finding the perimeter and finding the area. Okay, and then doing this one. Okay, now sometimes they're not going to have all the squares there. That's going to be called a composite unit. So this is a shape, rectangle here. You can see that's 5 feet by 8 feet. Okay, and there's no squares. But I can imagine in my brain what 5 squares would look like. Okay, and I can try to think, okay, well, I know that there's 5 here. Okay, so if there were 8 here, I could just continue that along, right? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And I could just kind of draw that on my own. Now, this is not something we want to be able to do. We don't want to have to draw all these out. But if it's something that will help you right now, then you can definitely do that. Okay, again, we want to be able to solve it, and tomorrow we're going to practice how to do this without any squares at all. But I want you to imagine, right, just because there are no squares, you're still counting squares, right? You can still count them even if they're not there. Okay, you could just draw them yourself if you needed to. Like I said, we're going to learn an easier way than drawing all these. But you can do 1, 2, 3, 4, 5, 6, 7, 8. But do I really need to do that? No, because this is counting by fives. So use our helper facts. So 5, 10, 15, 20, 25, 30, 35, 40. So the area here would be 40, and this is feet, so square feet. Okay, so I'm going to have you practice this with a little bit simpler problems, not quite as many boxes to have to imagine. Okay, but see how they have here the 4 and the 5. You can use that to help you. The 6 and the 7, that's going to be a little bit trickier. So what strategy would you use right now to help solve that? And then here, I want you to use what we learned about perimeter and area and use the composite squares and do this one on your own. As always, don't forget to reflect. And here are some extensions if you would like to practice either of these skills at the end. Thanks, guys.